Hello everyone and welcome to today's session Data Analysis and Statistics. Today, me Vivek Sharma will be presenting you and guiding you through this session. Data Analysis and Statistics is brought to you by Connect2Roots. Connect2Roots is a non-profit organization conceptualized, managed and run by a group of individuals who specialize in areas of social, information technology, economics, cultural and polity framework. They believe in civic-driven change, where the civic society take active participations and bring a proactive change to the society. Their motto is and their values are to act as a platform where every citizen of India staying outside their city, village, connect to their roots to fulfill their dreams and to give back to the same land to which they belong to. So, what is the salary and the job market of the data analytics? So, one of the surprising and the basic tools that we will come to know is Excel. Excel is a powerful tool for data analysis, reporting, and visualization. Data analysis extracting insights from the data-driven business decisions. The job roles that are available in the market or that can you take that after Excel or after a proper session of data analytics, you can take the job roles are data analysts, financial analysts, you can be operation managers, you can be business analysts. In India, the salary ranges from the entry level is 3 to 5 lakhs per annum, mid level is 6 to 10 lakhs per annum, and if you are experienced, you can even earn more than 15 lakhs per annum. The job market, so the data analysis is a growing market. Today this is a world of data. So the data is the new gold of this today's world. And in proficiency in advanced Excels and tools like Power BI and Power BI, Tableau, and uh, Python R will help you in many sectors, in finance sectors, in marketing, operations, each and every sections which includes data. So let's start into the session. What do you understand by the data, or how the data is collected? So if an organization suppose a nearby retail superstore want to know about their sales, want to increase their sales, how will be they be knowing that? They will be knowing that by collecting the data of how many sales they have done in this year or this month or in a quarterly basis. Once the data is collected, then data is cleaned. One of the important process that is involved in the data analytics is the cleaning of the data, because there will be many things that will be messed up or which will be wrongly entered from the operator's point. So first the data should be sorted, then data should be cleaned, then outliers are treated. In the later session, we will learn what are outliers and how can we treat the outliers. Basically, you can say that the outliers are some extraordinary individuals in a group. Suppose you have 10 students in your classes, and every students perform out of 100 they get 70 to 80, but there is one student who always get 100. So that is the outliers. Why it is important? Because if this person is not available in your classes, then your average marks of your class would be between 70 to 80 marks. But with the presence of this student, your average of the class will increase. Sometimes it misleads your data, because for a retail store whose income is monthly around 1 lakh to 2 lakh, suppose one day there is a festival and there is an income or sale of 1 lakh. So with the 1 lakh of sales, we cannot say that the average sale of the month is around 2 to 3 lakhs, because the sale on that day is a outlier. It's something that happens once, or something which is apart from other, which does not suit your rest of the data. But outliers are important, because by analyzing the outliers, we can know what are the reasons that driven that sales. So um, later in the sessions, we will learn how we can detect outliers and how what are outliers. After this, we can analyze the data and take data-driven decisions. While analyzing the data, we use many statistical methods, but there are basically two types of statistical methods. One is descriptive statistics and one is inferential statistics. So what is the descriptive statistics and inferential statistics differ from? So descriptive statistics is basically summarize and describe your data, while inferential statistics helps you to draw conclusions and draw predictions about your data. So what is the sample? So analyze the entire data set. So if you can see that from our earlier example, so for a sales perspective, it will see that the entire sales of every day. If you are seeing a sales of a year, it will see a day-to-day sales, and then it will take, if you want to do average, you want to do mean, median, mode, depend upon your data. We will be studying later how we will be doing various type of mean, median, mode, or other analysis. While in inferential statistics, basically inferential statistics, we use inferential statistics when there is large amount of data. For example, if you want to know how many healthy children are there in your society, it's impossible to collect each and every data, because there will be lakhs and lakhs of people in your society, and it will be impossible. So in that case, we take samples. So basically samples gives us a essence, or gives us what the population may be. For example, if we take a sample of 10 people and we found that our children are malnourished, we can say that from this sample we can say that most of our population, our children are malnourished. So this is one of the important things when we are dealing with a large amount of data. We try to take sample rather than taking the entire population. It saves your time, cost, and efficiency. Example: in descriptive statistics, there are mean, median, mode, range, variance, and many other things. Whereas in inferential statistics, we will be seeing what is hypothesis testing, how can we draw prediction, how can we draw conclusion, what's our regressions. Coming to the descriptive statistics. So what are descriptive statistics? Descriptive statistics, as I said, that initially is give the understanding and summarizing the data. The primary goal of the descriptive statistics is to provide a clear and concise overview of what the data main features. So basically, it will say what are its main features. So what are the type of data? Does it contain numeric data or categorical data? Categorical data can be of two types. One is ordinal and one is nominal. So what is ordinal? So basically what are categorical data? So if you want to say gender can be divided into some categories: male, female, or others. So it is a categorical data. Any data that can be divided or distinguished in categories, in some categories, not in some numeric forms, it's a categorical data. For example, so uh, for example, in the case of gender, we can see there are if there are two categories, genders, male and female, we can give it into two categories. So it's a categorical data. Now come into the ordinal and nominal part. So what is nominal? Nominal is that type of categorical data that have order in it or have some priority in it. For example, a nominal will be there is no order in it. So in nominal, for example, gender, in male and female, we cannot say that male is priority or female is more prior to the male. Both have equal priority. So we can consider both as nominal categorical data. Whereas in ordinal, we can say, for example, education qualification, high school, then graduation, then postgrad, then PhD. So it have a category. High school will come first, a postgrad will come last. It have a category, it have a order. So it's an ordinal. So descriptive statistics give us how your data is well spread. It gives us the understanding about your data, how many null values are there, if there are missing values or not, what are their outliers, how can we basically it's prepare you to do further analysis. This helps us identify pattern, trends, and characteristics within the data sets. So measure, it can be divided into these parts: measure of central tendency, measure of dispersions, measure of positions, measure of shapes or distributions. So what is measure of central tendency? In here we will be studying mean, median, mode, which offer insights to the center of the data distribution. Whereas in the measure of dispersion, we will be seeing what is variation, what is standard of deviation, and range. It will be help us how our data is spread, and it will be seeing how what are the kind of changes in our data, and it will be detecting our the changes in the data, and it will help us to understand more about our data. Whereas in measures of position, we will be mainly seeing our what is median, what is quartile period. So in basically, if you have a data with too many outliers, so mean will not be a good, because in the earlier example I said, if you have 10 to 20 students in your class and one student gets 100 while others scores between 30 to 40, then it will change the entire average of the class. Whereas if you leave this outlier, the 100 scoring student, then the entire class average changes. In that cases, if your data have too many outliers, generally it has categorical values, then we can go for median and quartile period, which will be studying later. Then we can see the shape of the distribution. By seeing the shape, by seeing the skewness, by seeing the kurtosis, we can analyze the data, we can draw inferences from it. Now coming to the descriptive data, there are two major types of analysis. One is univariate analysis, one is bivariate analysis, and you can conclude with your multivariate analysis. So what is univariate analysis? Suppose we are determining sales of a store, and we are seeing how many female are buying products from our store. Then we are taking gender as a variable, where we are considering only one variable, so it's a univariate analysis. Whereas if we see what is the gender ratio, and accordingly we want to see their location, from where, what are the places they are coming and buying products from my store, then we are taking two variables. One is the location and one is the gender. So there are two types of variables, so it's a bivariate analysis. And more than two types of variable is the multivariate analysis. So what is the central tendency of a data? So we know that central tendency consists of two types, three types: mean, median, and mode. So what is the central tendency of the data? Basically, central tendency of a data is the center of the distribution of the data. It helps you to understand the distribution, how your data is distributed. Either it is concentrated or it is spread, widespread, how it's distributed. It helps us to understand the data. It describes the location of the data and concentrates on where the data is located. The three most important is mean, median, mode. So after understanding mean, let's move on to median. So, so what is median? So you can see that it's a 50 percentile of the data. So it's the middle part of the data. If you have 11 data points, then the middle part will be the fifth data point. So it's the middle part of the data. So the median can be identified by ordering the data, splitting it into two equal parts, then finding the number in the middle. The central tendency of the data is not affected by the outlier. Suppose you have three data: 10, 20, and 30. So 20 would be the median. If you have 300, still 20 would be the median. So it's not affected by the outlier. So that's the basic difference between the mean and the median. So let's come to the mode. So what's its mode? The mode is the data is the so what's mode? The mode of the data is the most frequency occurring on the element in the data set. If an element occurs highest number of times, it is the mode of the data. Suppose we have 10 10, 20, 30. So the mode of this data set will be 10 because 10 has occurred 10 two times. There can be more than one mode in a data set if two values have the same frequency, which is also the highest frequency. Suppose we have another 20 here, so the mode will be 10 and 20. See, because both have the equal number of frequency. Outlier don't influence the data in this case. The mode can be calculated both for quantitative as well as the qualitative data. But if you can see that mode is very beneficial in uh, qualitative data. For example, we have a gender and we have one male, one female, and one female. So basically, the mode of this data will be female is 3 and male will be 2. So basically, for categorical data, mode is beneficial because we will be getting the highest number of, since it is divided into a certain number of categories. While as it can be also be beneficial in the quantitative data, but it's more logical using in the qualitative data. So now let's move to the dispersion of data. So what is dispersion of data? Dispersion is the spread of the data. How your data is spread. It measures how far the data is spread. This dispersion of the data can be measured by interquartile range, and standard deviation and variance of the data. What is the range? Basically, range is nothing. Range is the difference between two largest and the smallest value of the data. If you have 10, if you have 20, and if you have 30. So range will be the 30 minus 10, it's 20. So what is standard deviation? Standard deviation measures how far the data deviates from the mean value. Suppose uh, you have a data set, you assume that its mean is 10. But if you see here, what will be, there are 30 and 40, 50, 60 by 3, it's 20. So that's the difference. You have assumed mean is 10, but if you can see that your data set has been deviated from the mean value, so how many times it has deviated, and later on we will be studying how can we see how many standard deviation it has deviated from the mean value, and basically this is the standard deviation. So basically standard deviation, if you can see in this data set here 10, 20, 30, 20, it's 60 and 70, 80 by 4, it's 20. This 20 is not deviated, it's the mean value. This 30 is deviated in the positive side 10 times. This 20 is not deviated, it's 0, and this 10 is deviated almost 10 times in the negative side of this. 10 on this side, 10 on this side, it's equal to 30, it's equal to 10. So we came to know that standard deviation is something that how far the data deviates from the mean value. Standard deviation formula varies for population and number. Basically, we carry out standard deviation when we are taking sample and we want to predict for the population. For both the values, standard deviation have some little bit change in their formula and in the symbol too. The symbol for standard deviation of a sample is small s, whereas the symbol for the standard deviation of a population is sigma. Standard deviation is always positive or zero. It is always positive or zero. It can never be negative. Uh, it will be large when the data values are spread out from the mean. Obviously, if your data values are spread far away, for example, if it is 50 instead of 30 and it's 5, then its standard deviation will also increase because your data point is very far from your mean. So standard deviation, the data values will be large when your data values are spread out on your mean. So these are the two formulas, basically sample standard deviation and population standard deviation. So the sample standard deviation is summation of x minus x bar. So x is your individual observation. So 56, 76 minus what will be your x bar? X bar will be the average or the mean of these values, and squaring by n minus 1. N minus 1 will be the number, n will be the number of data points. So it's the sample. And in the standard deviation, you can see your same formula, and instead of n minus 1, it's n. And your new means, your new represent the same, it's the mean. It's the population actually. In population, we represent the new mean by mean. So let's go to variance. So variance is nothing different from the standard deviation. You can say that variance is actually is represented by sigma, and variance is the square root of the standard deviation. If you want to see the relation between standard deviation and variance, so variance is the square root of the standard deviation. So what is variance? Variance is a measure of variability. What are the changes in your data set or in a particular variable? What are the changes? How many changes are there? For example, if you want to say that there are three types of oil: diesel, petrol, and suppose a hydrogen. So there is a variance, there is a variability, there is a change, because petrol is not similar to diesel or diesel is not similar to hydrogen. So this is the difference. It is the average square deviation of the mean. The symbol is represented by sigma square for the population variance, and for the sample variance it's represented by s square. So population variance, as you can see, already said, it's nothing different from the standard deviation. It's actually the standard deviation formula of population, and it's the standard deviation formula of sample. So basically, standard variance is the square root of the standard deviation. Let's move forward and come to the shape of the data. So shape of the data is very important to know how your data is spread. It's symmetric or skewed, kurtosis. These are the three measures. How can we can see the shape of the data? The shape of the data is important because deciding the probability of the data is based on the shape. The shape of the data can be measured by the three methodologies: symmetric, skewness, and kurtosis. Symmetrics, as you can see, if in data analytics, when we analyze data, the data is spread in this way, in a bell-shaped curve, and we said this as a normal distribution, which we'll be getting later. We will be understanding how normal distribution is formed and what is the normal distribution. But basically, when we want to represent a data, we represent in this way. So this is a normal distribution in which in here this would be a mean, and in normal distribution, mean is equal to median is equal to mode. So if your shape is this shape is called the bell-shaped curve. So if your shape is symmetric, then we can say the data is distributed same on the both sides. You can see equal amount of data is here also, equal amount of data in this side also. So in the symmetric shape of the graph, the data is distributed in the same on the both sides. In the symmetric data, the mean and the median are located close together. The curve formed in the symmetric form is called a normal curve, and its mean is equal to median is equal to mode. Coming going to the next, what is skewness? So you can see this is a normal curve and it's symmetric. If you draw here straight line, so this is the mean, which is equal to median, which is equal to mode. But in the real life, it's very hard to get a symmetric data or a normally distributed data. So here we can see is a skewness. The skewness is the measure of the asymmetry of the distribution of the data. When your data is distributed asymmetrically, you can say it's skewness. Depending upon where it is skewed, it is if it's skewed towards right, it's rightly skewed. It's skewed towards left, it's left. As you can see, it's skewed towards left side of the data. It's skewed, so it's skewed to the left. If you can see, it's skewed to the right. Since its right side, its tail is long, and its head, this is called head of the data set, and this is called a tail of the data set. So the tail is long, and when your head is skewed on the left side, or when your head is on the left side and your tail is on the right side, then it is called the right skew, and when it is on the left either side, it's called the left skew. The data is not symmetrical, it is skewed towards one side. The skewness is classified into two types. One is positively skewed, one is negatively skewed. Positively and negatively skewed is just for the name purpose, nothing uh, which doesn't say about the values, that some values will be positive or some values will be negative, but it's a name given to it. In a positively skewed distribution, the data values are clustered around the left side. As you can see here, the data values are clustered around the left side of the distribution, and right side is longer. So data value are clustered around the left side, and the right side is longer. So we can say that your data is skewed towards right. Whereas in the in a negatively skewed distribution, the data values are clustered around the right side, and the left side is longer. Left side is longer. Basically, one of the thing we will lately learn, the skewness occur because there is outlier. When we see a skewness, we can assume that at the end of this tail there is an outlier. So here is outliers. There will be data points that will be lying here, for which your data is towards the skewed towards the right. So basically, there is outlier in this side of the data. If your tail is on this side, there is outlier. Second, here is outlier. So your tail is skewed. Your tail on the direction of the tail, there will be outlier, and so the data is skewed on the opposite side. Data is clustered on the opposite side. So there is outlier. So one of the major we can see from here is we can detect there is outlier by seeing just the curve. So what is kurtosis? Kurtosis is nothing, just it's measured to describe the distribution of the data. How your data, if you can see, it's in a scale. If you can say this is a scale, and this is a graph, this is one node, and this is another. You can see here its highest data point will be 10, then it will be 20, it will be 30. So it says how your data is skewed. If it's skewed like if it is like that, you can say it's leptocurtic, it's lepto, it's meso, and it's plateau. So basically, it's a name given to it. Now coming to the interquartile range. One of the important measure how can we detect an outlier, how we detect an outlier is through the interquartile range. So what are quartiles? Quartiles are specific percentiles. So basically in your Excel or wherever you want to detect outliers, we use a plot named as box plot. So this is a basic box plot. I have put here for you is a basic box plot. So in a box plot, we can see there is some quartiles Q1. So the median is the Q2, it's Q3. Then they say there are maximum, there are minimum. So what is quartile? So the first quartile Q1 is the same as the 25th percentile. So basically Q1 is the 25th percentile. Basically it's represent the 25% of the data is light here. 25% of the data. So Q2 will be the 50 percentile or the median. So basically till here, your 50, it represents 50 percentile of your data. It will represent 50 percentile of your data. So Q3 is the 75 percentile. So what is interquartile range? So interquartile range formula is Q3 minus Q1. Now we need to detect, how can we detect the outliers? So there are, so each at one we have to decide the maximum value of this. So basically this is the box and this is the whisker. So we have to decide the maximum and the minimum of the whisker. So the maximum formula is Q1 minus 1.5 into IQ1. The minimum formula is Q1 minus 1.5 into IQR, whereas the maximum formula is Q3 plus 1.5 into IQR. So basically after deciding that any data point that lies outside this maximum value or the minimum value is determined as the outlier. So if we have a data point of this as, think of as 5, it's 5, and your minimum is 8. Minimum is 8. Then this 5 and this 6 will be your outlier. In similar way, if it's come in to be 100, it's coming to be 100, then both this will be determined as the outliers. Maybe it will be 120, 130, 140, but with the help of this box and whisker plot, we can determine that how we how outlier can be determined. So as you can see, if we find the minimum and the maximum, then we can say any point that allow a data point of outside of maximum and minimum is considered as outlier. So coming to the empirical rule. So this is a normal distribution of your data. So basically this is your normal distribution of your data and this would be your median. This would be your mean. So the empirical rule is also known as 68, 95, 99 rule that it states for that for the normal distribution. Basically what it's determined that 68% of your data point lie at your one standard deviation, where 95% of your fall in the two standard deviation and 99% fall within the three standard deviation. So this is your mean, and this can be your first and this is your first standard deviation plus and minus first standard deviation. This is your second standard deviation. This is third standard deviation. So between both these first standard deviation, 68% of your data lies. Between second standard deviation, between this second standard deviation, 95% of data lies. Whereas between third standard deviation, 99.7% of your data lies. So any point outside of this third standard deviation is considered as outlier. So in this way also we can determine or treat our outliers. What is central limit theorem? Central limit theorem states when a sample mean from multiple samples are plotted, the result is an approximately normal distribution. This is because calculating a mean from any samples helps to even out high and low values in the sample. So basically when we collect samples, suppose we are collecting the samples of a population. So this is sample 1, this is sample 2, it has 10 data points, it has 10 data points, and suppose there are, in this way we are collecting samples. When we plot this, it always come to be a normal distribution because because calculating a mean sample helps to even out the high and the low values. Basically it even out the outliers. So in central limit theorem, the sample size should be sufficiently large. Otherwise we cannot get the normal distribution. This is usually met if the sample size is more than 30. This is a theoretical value, but it's not supposed to be every time that the sample size should be greater than 30. It can be something like that if there is a population, we want to know the breakfast of a population, and we are saying that we want to know that how many people are there who eat dosa. So if we want to know a population of dosa eating people, and we are seeing in the south, so there will be very less changes. So then we not need to take a large sample. We can carry out a small sample. But basically this is a theoretical value, so any sample, if you want to gathering a sample, should be always greater than or equal to 30. Samples are independent and identically distributed. Obviously these samples should not be identical, otherwise the whole thing of taking samples will be neglected. The population distribution have finite variance. So the population have variance, but it should have a finite variance. It doesn't mean that it should have infinite amount of variance. Otherwise, it will be not be possible for us to determine our objective. Larger the value of the sample size, better the approximation. As I said, that if you carry out sampling, larger the amount of sample you take, you will better your normal distribution curve. You will better be closer to the normal distribution curve. So it's always suggested you should take larger amount of samples. So now we will learning about the what is inferential statistics. So as I said earlier, inferential statistics will help us in taking decision or making prediction. The process of making prediction and make decision about one or more population parameter obtained from a randomly selected representative sample from the population. Suppose we want to know how many female are educated. So we are randomly taking one parameter, that is education, and one is gender. So from a population, and we want to predict. So this is can be done with the help of inferential statistics. Inferential statistics will help to infer to see whether the samples taken represent the population. Obviously, while we will be taking the samples, it will be also helping that if we are taking the correct samples or it represent the population. Uh, Sample mean and population mean may not be the same, and the inferential derived from the sample will not be accurate of the entire sample. If your population mean is something else and it doesn't come with same with the sample mean, or it's far away from the population mean, then the inferences derived from the sample will not be accurate and will not be accurate for the entire population. So what are its characteristics? Make inferences about the population from the sample, concluding whether a sample is significantly different from the population. Uh, for example, let's say we have collected the salary details of all the data science professionals in Bangalore, and you observe that the average salary of the data science is more than the average salary across India. Now we can conclude if the difference is statistically significant. Statistically significant or not. If adding or removing a feature from a model will really help to improve the model, we need to see. We will come to know how we can, if adding one feature. For example, if you want to know how many in your in a general store, what is the average sale? So there can be many factors. Gender is one attribute. Uh, Location will be one attribute, income will be one attribute, discounts will be one attribute. So if it's a regular customer or not, it can be one attribute. So all the other the feature, uh, removing or adding one of the feature will improve your model. You need to see repeatedly, so understand how our model perform better to do prediction, and in this way we will select our feature if one model is significantly better than other, and in this way we can determine how our for example in model 1 we have only selected the gender and location. In model 2 we have selected the income also. But if you in one model we have selected only just the income, and the model where we have selected only income is coming out to be good, is showing accuracy of almost 80% or 90%, 95% more than the other model, then we will better to choose that model. Hypothesis testing and testing in general. So we will be doing hypothesis testing. We will be knowing what is hypothesis testing. So we will be coming later how to know what is hypothesis. So basically, confidence interval is the type of interval estimate from the sample. It gives a range of values in which the population statistics may lie in the confidence. Because suppose there is a pharmaceutical company and prepare a certain type of medicine, and each tablet contains 28 or some amount of medicine, and if there may be sometimes that it not may contain the optimal amount of medicine in that particular tablet. So the company may lose a lot of money because a huge sum of if someone sue that company, a huge sum of money may have to pay to that particular individual or particular organization. So confidence interval is estimated. So confidence is the you can say confidence interval is in some way like that. If your confidence interval is 95%, then you are confident that 95 out of 100 times estimate will fall to the upper and the lower value specified by your confidence interval. So if you say that your confidence is 99%, then 99 times your statistics, your population statistics will always lie uh, within that range. There may be one time it will not lie. So in such way, uh, company can safeguard their moreover. Uh, the company may also able to save themselves from suing by other persons. So basically, confidence level is determined by alpha, and the confidence interval level is usually is 1 minus alpha. So if your alpha value is 0.05, your confidence is 1 minus 0.05, it's 95%. As I have said earlier, 68% represent that your 68% of the data is within one standard deviation. So this is mu. Mu is the sample mean. Mean means one standard deviation to plus one standard deviation to minus one standard deviation, 68% of your data. Whereas between two standard deviation, 95% of your data lies, 99.9% of your data lies within three standard deviation, and outside that will be your outliers in these cases. Now coming to what is hypothesis testing. So hypothesis testing is basically a statistical analysis of it's an assumption. It's an assumption, or you can say a statistical analysis about your population parameter. Now, to test whether your sample will be lying with your population, or whether your population is within the specific range. So there are while defining hypothesis, there are two types of hypothesis. One is null hypothesis, one is alternate hypothesis. So what is null hypothesis? It is a statement which is particular value of the parameter which is predetermined from the experience or prior. Whereas in the alternate hypothesis, it is a statement that specifies the objective of your studies. For example, you want to know what is your optimum oil for your car. So what will be the null hypothesis? Suppose there are four types of oil: diesel, or some um, diesel, petrol, or hydrogen, or other type of oils. The null hypothesis would be that none of these oil have a significant influence on your car performance. Where your alternate hypothesis would be any one type of oil will have a definite or significant influence on your car performance. So to determine this, there are many type of tests we do in the population. There are t-tests, z-tests, ANOVA. So what is a t-test? So t-test is a statistical test that compares the means of two samples. It used in a hypothesis testing. With a null hypothesis, that is the difference in the group, which means zero, and an alternative hypothesis, the difference in the group that is different from the zero. There are three types of tests in t-test. One is paired t-test. So paired t-test is when we want to investigate whether there is difference between within a group. So if you have a group of students in your class, what is the diversity in that class? Some people may be of south, some people may be of north. So it's just checking there what is the differences within a class. Independent t-test will be something when there is two groups. Suppose there are two sections, section A and section B. And what is the difference between those two sections of the class? And one sample t-test is something that I was mentioning, that if you have a population and if you have a sample, and how this sample is related or how this sample is different from the population. And this is all about your. So Z-test is also similar of the t-test. It is also to determine population means, how two population means are different. But Z-test and t-tests are taken if you have a small sample size. If you have a small sample size, see, the Z-tests are closely related to t-tests, but t-tests are best performed when the experiment has a small sample size. If you have a small sample size, we go for t-test. If you have a large sample size, we go for Z-test. Now, what is ANOVA? ANOVA, as you can see from its abbreviation, analysis of variance. So in this we compare the two different groups, how the two different groups are different from each other, or what are their variance within the group and also between the group. For example, if we have a two section, more than, if you have three, suppose in a class of three sections, class 3, class 12, section A, section B, and section C. So in ANOVA, if you want to see how this section A is different from the section B, how section B is different from the section C, or how section C is different from the section C. In the same time, we have also different students studying in the same sections. Some people may be of north, some people may be of south, some people may be of northeast. So it will also help to determine the variance within the group and the variance between the group. Now, coming to the regression. Regression is used to understand the relationship between two variables, particularly focusing how one variable, which is the independent variable, influence the other variable, that is dependent variable. So, dependent variable will be always your objective variable, and it is determined by y, whereas your independent variable will be your x. So, if you want to know your sales, a department store manager want to know the sales in a month. The sales will be your dependent variable, while how your sale is influenced by location or by the income group will be your independent variable. So it has two type of variable. One is independent variable and one is dependent variable. And what is the relation? And in regression, we want to see how this independent variable influence the dependent variable. So types of regression. You can simply see regression as a simple equation of line. So in a simple equation of line is y mx plus c. So you can see the regression equation is also similar, where c is your intercept. In here also, this is your A is your intercept, where x1 and x2 or x3 will be your independent variable. If it's what is a simple linear regression and multiple linear regression. The simple linear regression will be if you have one independent variable, one could trying to influence one independent variable. When we are saying how one independent variable is influencing the one dependent variable. In multiple linear regression, when there will be more than one independent variable, how it's influencing the dependent variable. It's known as the multiple linear regression. Basically, it's the same. When how gender is influencing your sales. It's a simple linear regression. How gender, location, and income of a particular individual is influencing the sale. It will be multiple linear regression, and this will be a simple. This will be a regression equation. So here we can see where A is the intercept and B1, B2 will be the coefficient. So if B1 is positive, then X1 is directly correlated. For example, if B1 is positive, this shows the strength of the relationship between the independent variable and the dependent variable. A positive coefficient suggests that if X increases, Y increases. Whereas a negative coefficient it shows a negative relationship. It shows that X increases, Y decreases. So